Hello everyone. So I will explaining part of the experiment for this course. Um, so I will guide you how to design the PCB for a buck converter. So I will remind you again a little bit about buck converter. So buck converter is a converter that will reduce the voltage from input voltage to lower voltage on the output. It consists one switch, one diode, one inductor, and then in the circuit is one capacitor. But you can add more than one. And then in the real life application, usually we put uh, one or we put a input capacitor because usually maybe the, uh, the input is not directly connected to the supply, so it will have a parasitic inductance. So the minimum circuit is like this. So in here we replace the switch with MOSFET, the N-type MOSFET. So to design the PCB, the software that I use and I recommend for you to use is called KiCad. So this software is open source, and right now the version is 9.0.6, but I recommend you to install the point 1 because on the point 6 there is some part that is missing that I need. It's only available on this version, so you can download on this link and install it. So before we go to the software, I will explain a little bit about how to control the MOSFET. So usually to drive the MOSFET, we cannot directly from the we cannot directly connect it to the PWM module or microcontroller because the voltage usually is lower than 5, while MOSFET to fully operate, the gate should be supplied from maybe 7 or 8 up to 15. That's the voltage range that uh, have good performance. And we can see in here there is the graph. While the gate voltage is increased, the current that can flow is increasing. So to open is so we can imagine the MOSFET is like a valve that if we put a full voltage like 15 volt, it will be open fully, so the flow can flow. I mean the maybe the water or the current in this case can flow without any resistance like this. And then because the position of the switch in here, so the output of the switch will be floating, not directly connected to the ground. So we need some like it's called virtual ground. um, so to accommodate that problem, uh, there is two ways to uh, drive the MOSFET to supply the driver for the MOSFET. Usually we can use bootstrap capacitor circuit or isolated DC-DC converter. So isolated DC-DC converter is more easier, more compact, but it will be more pricey than bootstrap capacitor. But for this time we will use isolated DC-DC converter. Okay, so we move to the software. When you open the KiCad, you will find this. After you install the program and start the program, you will find this page, and then in here you can start directly to here, file, new project, and then you can put make the new project for the PCB, and then you can put the name in here, maybe like buck converter project, and then in here there will be some option. There will be make a new folder for the project, so you can check this one and then save. After you save, you will find like this. There is two files in this project, one for the schematic and one for the PCB design. So first we need to put some part of the schematic, so just double click and it will be open like this, like a blank paper. So the important things of the schematic in here, on this, I think this on the right side. So on the right side is everything you need to put some component, the connection between component to this paper. So for the in here, first we need the input source. So for the input and output source, the output, you can go to this symbol, like a ground symbol. So this is like power symbol, and then in the power in here you can see many things that you can use. It's up to you. In this case I will use 24 volt. You can double click, and then to zoom it you can scroll using your mouse, so like this. And then we need another, just click again. We need ground. You can use this ground, this, and then you can put maybe like this. And then you need for the output, because in here I designed for 12 volt output, I just use this symbol for the output, like this. And then for and the component, the symbol selection, you can press escape button on your keyboard, like this. And then you can move the page by using the right click on the mouse, like this. And then you can copy for here, like this maybe. So we have input and then we have output. And then if we see on the schematic again, see again, on the schematic, so there is some input capacitor, MOSFET, diode, inductor, and then the output capacitor. I put 2 output capacitor. So let's make this to the schematic. So we need for the another symbol beside the power, you can click this one, and then we need capacitor. So the symbol, there is many selection that you can use. I usually just use the small one, like this, and then put here, and then you can connect it directly to another symbol, and then you can copy it for the output, just like Control C and Control V, like this, and then you can connect it like this. And I usually love to make it for good looking how to say it. So yeah, like this. And then we need MOSFET. For the MOSFET, you can type it MOSFET like this, and then the transistor FET like this, or you can use NMOS, yeah, like this. But be careful. I usually, because in here many selection, so like DGS, it means that this will be drain, gate, source. You need to be careful about the numbering, because in the general MOSFET, usually the pin number, usually it will be GDS, gate, drain, source. So the number 1 pin should be the gate, number 2 drain, and then number 3 is source. So we choose this one, and then you can put it like this. And then, because sometimes I hate this, you can delete this one, the value of the component. Actually didn't use that things. And then like this, you can make it more far, and then we need some diode. Just type it diode. And then for this one we need common anode 1 2 3. Oh, so the middle should be anode, so KAK. KK? No. AKA. Yeah, this one. The type of the diode that we will use is like this. So we can put it like this. Yep. And then we can pull this more longer, giving more space. These two. Like this. And then this thing should connect to the ground. And then if you cannot, usually you can directly click this circle to make the wire, but in here, if there is no circle in here, you can go here, draw wires, or click W button on your keyboard and just make it like this. Ding. Then this should be connect to here. Oh no, I will connect it later. So like this. And then we need inductor. You can type inductor like this, and then you will find this one. I use L small. Oh yeah, to rotate you can click R button on your keyboard. So it should be like this, and this one connect to here, think if we follow on the page, should be like this. We can move to it down a little bit, and then like this, or you can pull here like that. Yeah, so we complete the main component, the capacitor, switch, diode, the inductor, output capacitor, and then for the output voltage like this. Then we can go to the put some like what, link, connection link in here. So we can use what is called label, place global labels, and you can give it name like gate for the gate of the MOSFET, and then click again source for the source pin of the MOSFET. Oh yeah, before on the gate of the MOSFET, we need to put some resistor to damp the oscillation that happen because the parasitic inductance. So we can add some resistor, just type R like this, and I use the small symbol, and then we need another resistor to pull the MOSFET to the source, to pull this gate to the source. So there is no chance that the MOSFET will false turn on, because sometimes maybe there will be some capacitance on the gate and then the voltage rising because the EMI or something like that, and then make it falsely turn on. So it's not good. This is just prevention, so it's not very necessary to add it, but I will put it. And then oh yeah, you can move the text in here to make it more prettier like this. So let's see if this is exactly the same. Yeah, I can say maybe almost same, but yeah, you get the point. And then next we move to this part. So for the PWM module, the IC, we use TL494, and then this configuration I already designed it to be a single-ended configuration. So it means that, this PWM model, you can use it for push-pull configuration or single-ended. So in push-pull, you will use it for half bridge, full bridge, and something like that. On single-ended, you can use it for buck converter, boost converter, and then another converter that only use one switch for the switch. On one switch for the circuit like this. So you just follow this one. So we will make it back to the software and click this one. Just type TL494 like this, and then just follow me. Just follow the schematic that I giving before. So because I will make it this video more faster. It's we can pull this name is the PWM like this. So this should be connected to the ground. Yep. And then this one. Then we need some variable resistor, air variable like this. Yeah, you can choose maybe this one, no, the potentiometer. So this one, but I prefer small one like this. We can rotate this one like this, or this one like this, if we follow the schematic. So yeah, this just connect to the RT, this one same, and then this one to here like this. Then we need another for this one, but position like this. But in the schematic, the pin number 3 and 1 will be flipped, so we can mirror, yeah, like this. And then this should be connected to the DTC pin, and then this should be connected to the reference. Then I will move this to here. Now we need another capacitor in here. Yep, we move to here. Then I need another capacitor in here. Sorry. Yeah. Then like this. So finish. So for the control IC, it's like this. You can follow like this. So I'm sorry if I make it so fast, but you can pause on the video and try to make it like this. And then we move to the driver for the MOSFET. For the driver we use HCPL 3218. it should be 3180 like this, but in here it doesn't have the symbol for this one, so we use its brother at CPL3120. I mean the symbol and the pin is exactly the same, so we can use this one. We put it like here, and then for the isolated DC-DC converter for the supply, in here we use the symbol for the ITQ2415, the S version. So this one, and we can put it in here. Yeah. Oh, sorry, it should be ITQ2412. I mean it's the same, only the name, but the pin is same. So we can use this one. Like this, put like this, and then this one. So this is the input for the driver, and then this is the output that connect to the MOSFET. So we need the connection that connect to the MOSFET, that link to the MOSFET. So we copy here gate, we make it like this. You can pull like that, and then this is should be connect to the source of the MOSFET. Yeah, like this. Like this, yeah. Or up to you. So, and then we need this one connect to here, and this one connect to here. So maybe better to like this, and then we need some capacitor on the output of the converter like this. And then for the input we copy it from here, PWM, and then we need the ground. And this one connect to the same source of the input source like this, and then this one same, and then we add another capacitor in here. Yep. Oh yeah, for the capacitor in here I will use the electrolytic capacitor, so it will have some polarity. For these two we can find in here the symbol polarize, and the small like this. Yep. Yeah, I will delete the name. Oh, and then I will move the number, and then why it's so hard? Yeah, like this. Move again. Yeah, and then we copy to here, same. Okay, we done for the driver of the MOSFET. So in here you can see that the inside of the driver. So is almost same as optocoupler. So the input side will be isolated from the output side. So the ground in here, and then we can say the ground for the MOSFET is isolated, so it's not connect in the same node. So it's a fully isolated power for the gate MOSFET. And then the last thing, back to the schematic page, we need the socket for the input and then the output. Then just go back to the component and type socket. But better you type connector, con, like this, and then click this one, 1x2, and then make it 2. You can copy this one like this, and then make it 1 for the input with the ground, and then the other one for the output. I will make it lower. And don't forget the ground. Yeah. Okay, we finish. So in here, actually, for the ground, for the input and the output is on the same node, so we can use only one, it's okay, or you can put 2, is okay, because it's same, it's on the same node. So for the schematic already complete like this, and then the next step is to assign the footprint for every symbol. So the schematic is only like the blueprint, but after you make the schematic, you need to know what size or how the component looks, and then what type the socket that you will use. Like that is from the assign footprint in here. So in here you can choose the type of the things that you want to use. So in this example for the C1, this is the capacitor, but capacitor many size, many type, like ceramic or mylar or something like that you can use in here. So there is SMD, THT. So SMD is for the surface mount. I forgot the D for so it's only on the one side, not like yeah, you can find on the internet about that. And then in here we will use the type is the THT, so it's through hole, so it have like a long leg that will through the hole of the PCB. So we can double click, and then on the right side you will find this, and then you can see the picture, the image of the footprint by click right and view selected footprint, and you will see in here. And then if you change, we'll make it little smaller so we can see. So if we change, the picture will change, so you can choose what you want for the capacitor, or you can follow the slide. So I give you on the slide the type. So we can next. So we can move to here. Usually the numbering for the capacitor will be not exactly the same, but I will give you some clue that for the input capacitor, uh, the input, the output, and then the capacitor for the converter, the isolated DC converter should be electrolytic. So for the input and the output source, the size is larger, so is 8 millimeter. So maybe we back to the in here the software. So like this. So for the C1 in here, for the C1, my C1 is the input capacitor. So for this one I use the size is radial with 8, yeah, this one. So this one. And then you can assign it by double click like this, and then you can copy it for another capacitor, just like Control C, Control V. So C1, C2, and C3 will have the same size, so we can copy this one, Control C, and then paste on the C2 and C3, right? Yeah, paste C2 and to C3. And then for the another capacitor, for the C4, for the C4 in here, it should be, all of them should be this ceramic capacitor. So it's this, but for this one it will be have smaller size than the other. So we go to the software again. I mean for the assign footprint, and then so it means that only the C5 that have this one. So go to this for the C5, and then find this with 3 millimeter. Yeah, this one. We can see the picture. So where is what happened? Oh, this one. Yeah, so it will be like this, look like this. Okay, close. And then for another C4 is have a larger 4.3, and then we can copy and paste for C6 and C7. And then for the C8 and C9, it should be same. Oh, no, it should be polarized but smaller, and we use the radial with 6.3. Double click, and you can double click again, so look like this. And then for the dual common cathode diode, we use the TO package, TOTST 220 22035. vertical, 2203 vertical. So you can see it looks like this, the pin. We can double click, and for the socket for G1 and J1 and G2 we use connector banana. We can go to the connector and banana jack 2 pin, double click again. And then for the inductor we will use banana jack the connector. So we make the inductor, and then the 2 wire, the inductor, we will use banana jack, so you can put it and put out. It will very convenient for our experiment. So just double click again, and then for the converter, yeah, it's correct, automatically assigned. And for the NMOS GDS, it's same, the package with the diode. So just copy from the diode and place on the CMOS, the MOSFET. And then for the resistor, all of them using the same size. For the size is, we can go to resistor THT and go to axial 6.3 axial 6.3 with length 6.3 and diameter 2.5. but the 6.3, this one we use the P7.6, so it will be like this. Double click, and you can double click again, and then for the potentiometer or variable resistor, we can use go to potentiometer. Where is potentiometer THT, and go to Burns with this one. So number 42, 3296 W vertical. You can see, yeah, like this. And then I forgot for that. So same, both of them. And TL494 should be, the package should be package DIP with 16 pin. So DIP 16, this one we can see to make sure, like this, and double click, and for the HPL is automatically assigned. So after we assign everything, we can apply save schematic and continue, and okay. So we already assigned the footprint. We click this button to switch to the PCB editor, and then you will find this one. And then to put the component in here, we need to update based on the schematic and then the footprint that we assigned before by click this button, and then just click this. I usually just do this one and update PCB, and you will have all of the component from previous schematic. So in this page, on the right side there is a layer side. So this layer, it has some name, because in the basically on the PCB, when you manufacture in PCB on the professional manufacturer, there is many layers, not only the board and then the copper, but usually there will be silk screen and then some film that cover, and then the text that they will put on the PCB is based on this layer. You can divide it into some part of layer, but the main layer, the most important things is this one, these two. So there is F for the front copper layer, and then B for the back side of the layer. So when we see this this screen, is we see in this from the top view. So on our experiment, we will use the single side PCB. So we will draw our copper layer using this one, the back copper layer. So first we put all of the component. You can follow the slide. We back to the slide. So I already make it like this. You can follow exactly like this. So we will try. So first put your input source like this, and then your output like this, and then for your inductor like this, and then because in here I put some space for our inductor, so we can, and then make some hole to put some zip tie, so we can make the inductor to stay and looks pretty like this. You can, so we back to the design. So we can use the circle, click, and you can make the diameter. So the outer diameter is 40 millimeter, so it means that the radius is 20 millimeters. So, or you can put like this, and then double click, radius 20 millimeter, and you can put it to here, and then we make the copy and make it this one smaller. So the inner radius is 10 millimeter, and you can put it on the middle. So how to make it exactly on the middle? You can click this one and hold the control button and click the other one. So there will be two selected component in here. So you can right click and go to where align or distribute. So we can align to horizontal center and then align again to vertical center, so it will be exactly on the middle. And then you click again two of this to make this on the middle with the top component. Yeah, like this, and then same, I will align to the circle, so it will be on the middle. We can pull this out a little bit to the right for the capacitor. So, and then next we put the output capacitor is the C2 and C3 like this, and then should be like this. Yeah, and then I wanna make this exactly on the middle. Yeah. So this same, so it will be like this, and then after that we can move this a little bit. I want to make this on the same side. Yeah. We can move it a little bit again. Okay, so we put our MOSFET in here. Yeah, you can, I will put it right here, and then the diode is right here. Because I don't like to see this name is it's not comfortable for me. You can hide it by hide the front piece. No, silk screen. No, I forget. But we can try one by one. Yeah, the FMB fabrication. Yeah, I don't like to see it, so it will be more clear to see. And then I want to make this line too. Okay. Then you can put this one in here, but we need to rotate like this. Maybe same as on the same position as diode. I will make it align again. And then for the control IC should be like this, and for the driver IC should be in here. So this should be like this. Okay, and then for the input capacitor I will put it, oh sorry, this the positive should be on the top. Okay, mixture again on the middle line, and then so same for this one. Okay, so we put the rest of things. I think this one should be connect to here. Yeah, we put this one in here, and then this one in here, and then this one should be here. Thing like this, better like this. And the RV2 like this. And then the smaller capacitor is right here. You can align it with the pin. Just click the pin. Yeah. And then the C4 in here, it should be connect. I think this one. I think this one is here. And I want the pin of the ground is aligned with the pin ground of the converter here, so you can do that. And then for this one, the C6, I think this one here, and I want to align again with this one. here. This one is should be like this. I will maybe make it align with this one. Can I? Oh yeah, I can. And for the R1, I will put it for the get resistor. I will put here. Yeah. And I will put align with the gate pin. So I can move it to here. And then for R2 should be the pull down resistor. I will make it to align. Hey, no, you click first the component that you want to align it with the component that has the base for the line. No. Only the pin. Yeah, like this. And then for this thing, I can put this in here. Like this. You follow the slide. You can follow my video, because on the slide the numbering is a little bit different, so you will little bit confused to follow that. And this one I will put it here. This should be moved a bit. And I want to align it with this one. Yep. So I put it a bit. I want to align. Oh no, only the pin, not the component. Yeah. So you have, after we put the component, it will be looks like this. I will. So you just connect the wire, but you need to specify the width of the wire by first click this one and edit predefined size, and you will found this page, the tracks, the vias, and then differential pairs. But the important things I think is for the tracks. So usually I will use just make some size from 0.5, 0.7, or 1 or something like that, like this, and then just click OK. So for the control part, so we can say this is the control part. I will connect it using 0.5 millimeter size of the wire. So click this one, the root single track, this, and just connect everything, like this one to here, this one to here, and then sometimes you need to find some way to make all of the component connect with without some jumper. So I will make it little bit fast, but you can pause it later. You can pull it like this too to make prettier. And then this one can go here. I will rotate, so we'll align the pin so it can straight and go here. You can make it like that, and then this one connect to here, and this one will take around. I will connect it later. So you can follow on the slide which way you can connect it, and then this can be connected to here. So we make it like this, and then this one will connect it to here. And then like this, like this. Yeah, and then connect this one to here, this one to here, and this one to here, this one to here. I will make it like that, and then this one to here. Just make a little turn. Yeah, and then the source should be connected to here, and this should be here. Move it a bit. So like this. Then this one I will yeah, like that. And then another ground, we can connect it like this, but I don't like straight like that, so we can undo and then make some like this. Yeah, I think better like this. Then we can connect the ground directly, and then this one can connect to here. Oh, I don't like. You can pull up, pull down like that a little bit and make some corner and going back like that. So yeah, you get the point. And then this one connect to the ground, and this one to here, this one to here, and then we need 24 going up through here. I will pull, yeah, like that. And then can make the ground that connect to here, and you can connect the ground to here, and this one to here, and this one to here. One to here, so we'll make it pretty. We make like this. Oh no, I will delete. I think I need to connect it to this first. Yeah, like this. And then this one should be to here. Then this two should be connected. Oh, so I need to make be like this. Yeah, sometimes it's little bit hard to find the best route for your connection between pin. You need to try and find the best way, and the most efficient way to connect. So like this one should be connected to there. So need to go here, and then yeah, like that. So and then yeah, for this one we can use the front connection like this, but actually in our PCB later we will use a jumper, some wire, because we only make the single side PCB. And then same for this one. I will make this one. I will delete this first, so I can pull. So I can pull this little bit. So I have space for this road. So like this, and then you can put vias, this orange, and then go to the front again and make it like this. But yeah, we will use some wire to connect these two trays. And then you will think, why it didn't connect to the this one? We don't make the ground connect to this ground, because I want to isolate the ground connection, not isolate it, but I want to differentiate the trace for the ground for the control, and then ground for the power, the circuit, I mean the trace that have the higher current flow. So after we do that, for the high current trace, usually I will use what's called fill zone. So you can draw some space like this. You click and put it. I will start from here. Click this side, and then you need to choose which node that you want to draw. So in this case I will try the 24 volt, and then the pad connection change to the solid, and then the corner smoothing used to fillet and put it maybe 1 millimeter is okay. And then oh yeah, the layer is the back side like this. So I will make this to be like this, and then to here, I think. And then oh no, not that far, sorry. Escape again. I will make it to back side. Click again, 24 solid fillet 1 millimeter. the size should be, I think, this, and go to here, go to here, click to here, to the MOSFET pin 24 volt, to here, and then make some space, maybe this size, and then go back to here, and now we'll make it to here. Yeah, so you will draw some shape for the area that will be filled by the zone, by the copper. So after you draw like this, it's still empty. After you draw, you can press B on your keyboard and it will be filled. Yeah, so it will be filled like this. And if to close with the another node of another connection, it will be automatically delete that space. So it will be follow the, it will be like adjusting automatically. So this is for the 24 volt and then node, and then we make for the source volt, source node. So source will be connect the source of the MOSFET to the diode, the output of the diode, and then the pin of the inductor. So we can make that like this, and then source solid, wait a moment, and then fillet 1 millimeter, and then I usually make it like this. And like this, and then I will give some space, and then like this. Yep, and then just press B again. Tada. And then I will adjust the size to follow this. Yeah, I mean this as the limit. Usually I just follow that. So I will adjust this one too, same. Press B again and it will be like this. And right now for this side, you can make again like this from here. So it should be 12 volt. The net is 12 volt, solid, corner smoothing, fillet 1 millimeter. And then I think this one, so it will be cover the 12 volt pin of the capacitor, and then it will be end in here. I want to make it straight, so you can follow the dot to make sure if straight or not, and then just press B. Oh, I forget, when you draw this, both of this, you need to make it a silk screen, so it will be not count as the copper. So we can change, because previous is, I mean right now is copper. I want to change it into silk screen. So you can just like control and click this one, press control and click this one while holding the control, and then change to silk screen. No, I'm sorry, not like that. So we back to this one, we can double click, and the layer should be silk screen, front silk screen, same as this one. Double click and change the layer to front silk screen, and if we press B, it will be like this. So it will be the zone of the zone will be not count the draw of the circle as the cover, so it will be not have some effect on this zone. And then we make for the ground. For the ground, it will be a little bit big, so I will start from here. Yeah, I think better this. And ground solid fillet, and follow the shape of the 24 volt, so it should be like this. Go to here and go to here and go to thing. Shape should be like this one, and just pull to where, to here I think, and then this one to here. So this is like a single time driving, and we can make to here, and then go here, make some space here, make some space again, and usually I just make it same like this. I mean the same size like that. No, don't go there. So here, and then this one should be this dot, so I can pull this directly to the capacitor. And then this should be cover the connector thing like this, and then just pull to here. Oh no, I forgot to click. So click, and then finally click this one. So the zone will be like this, and you can press B. So you will have this zone. But maybe for the ground is the trace is a little bit small. You can make it larger like this, or you can make it equal as the trace for the upper side, I mean the 24 volt, like this. And then you can make a drill hole for the stand of the PCB, and then for the zip tie by type the component, I mean this one, footprint, and just type hole, mounting hole, and then go to the, I will use 3.2 M3 and just put it on the middle like this one, and then copy this one to have a maybe like this diagonal, I think like this. And then this is for the zip tie, and then we need for the diagonal, I mean for the stand, put here and then put here. This one too, same. I will put in here and put in here. Yeah, and then we finish our circuit. Oh yeah, the last part, you need to make the line for the edge cut in here, this line. So click edge cut and then draw the rectangle. Just click the outer part like this and then finish. So after you make the PCB, you can see the result. I mean, you can view the 3D version of your PCB by click this 3D viewer, and you will found like this. Yeah, it's great. You can imagine the design that you will build when you finish. So yeah, don't forget to save. Okay, we back to the slide. So yeah, finally we finish our build. So please try, and then if you have some problem, you can contact me, and see you later.